Welcome to another edition of Math is Easy Step by Step. So still we're doing a little more examples of dividing with exponents. Since this takes a little bit of time and I'm limited on the length of my videos, I wanted to break these up so I didn't feel rushed and I didn't feel like I was rushing you. So let's do another example. Here's example number 5. And so here you can see we have 12x to the 12th power times y to the 5th power divided by 24 times x to the 10th power times y to the 6th power. Remember, these terms are joined when they're together like this without any symbols in between. They're joined through multiplication. So I'm going to show you, I'm going to break these down fraction over fraction over fraction connected with the multiplication symbol. And you could take these and break them down into their simplest form, which we've talked about in previous videos as expanded form. And if you're unfamiliar with that, I advise you to take a look at some of the previous videos I have made regarding multiplying, dividing with exponents. So let's go ahead and take a look. And these little arrows here indicate, hey, we're moving on to the next step in the process. Let me show you what that looks like here. So I'm showing you how you don't have to use the expanded form. If you understand that 12 divided by 24, 12 divided by 24 can be reduced by dividing 12 into top and bottom, you can reduce or simplify this fraction, because I know 12 times 2 is 24, and I know 12 times 1 is 12. This fraction, 12 over 24, as we broke it up into 3 parts, can be reduced by dividing top and bottom by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So I'll rewrite that in my answer if I don't simplify further. And again, when you are dividing with exponents, the rule is you can subtract them. And we have the same base here of x and x. So 12 minus 10, I'm showing you here, times y is 5, y to the 5th power divided by y to the 6th power. So 5 minus 6, I'm showing you here. And in the next step, we will simplify, combine like terms for our final answer. So here I'm trying to show you, and this was again the advantage to doing expanded form. You could see what terms would end up in the denominator, the bottom half of the fraction. But here I'm just showing you another method that you can use, another way to get to the answer, right? So we reduce 12 over 24 by 1/2 times, 12 over 24 reduces to 1/2 times, x is 12 minus 10 is x to the 2nd power times y to the 5 minus 6 is y to the -1. So here it's important, and I will go over negative exponents in another video because that's another rule, exponential rule. But right now I wanted to express to you the importance of understanding the invisible ones in the denominator's place. So here, underneath the y, in fact, even underneath the x, unless there's a number indicated in the denominator like we have here for 2, there's an invisible 1 underneath this term. And I'm showing you using the dot, there's an invisible 1 underneath this variable of y. So the purpose for that is, in order to change this negative into a positive, you flip the fraction. So 1 is now on top. 1 times 1 times 1, right? That 1, we're going to flip. In order to turn that positive, we have to flip the fraction. So now it's 1 over a positive y to the 1st power. So you flip this fraction, and again, you have an invisible 1 in front of that x. So 1 times 1 times 1 is 1 x squared on top. Now we also have that 1 on the bottom. And there's a 1 in front of that y, right? Because we flipped it. It's 1y to the positive exponential power now. So 2 times 1 times 1 times 1. I'm sorry, not thinking about this. We flipped that fraction. It's right here. So 2 times 1 times 1 is 2. And we keep that y to the positive 1 on the bottom. Another way to write that, again, I'm showing the 1/2, but you don't have to put this 1 in front of x. You absolutely can leave it in this form, 1x squared over 2y to the first power. Or you can show it in your answers without the invisible 1, so to speak, in both of the coefficients place and the exponents place here, showing you in the exponent. So this would be an invisible 1. You can leave it in either form. Both of these terms mean the exact same thing. So that's our simplified answer. We have another problem here, example number 6. And these are getting a little more complicated as we go along. So I wanted an extra amount of time for this video. So we have 3 over 12 times 3 times x to the negative 2 times z to the third divided by 12 times y to the negative 2. So we could simply, in order to turn, remember, to show these fractions, in order to make this negative a positive, we can bring it up here to the numerator. To take this negative 2 attached to the x, we bring it down to the denominator, and then we leave everything the same. Write it out in expanded form. Expanded form. So, again, that x over a negative 2, we would just flip it, and that makes 1 over x to the second power. Right? 1 over y to the negative 2, we flip it. That y to the positive 2 comes on top. That 1 is on the bottom. So all I did here was I took the 12 and wrote it out expanded form. 3 times 2 times 2 is 12. Times, remember that x squared is now on the bottom. We flipped that fraction and brought it down. You simply bring up that y squared on top. You have 3 times y squared times z to the cube, which was always on top. And from here, you just simplify as far as you can. Showing you here 3 over 3 reduces to 1. And that's all we can do. 2 times 2 is 4. X squared, that remains on the bottom. Remember, 1 times the invisible 1 and the invisible 1 in front of these two variables. 1 times 1 is 1. Y, z. 1y squared, z cubed. Or, you don't have to show that 1. You can rewrite it as y squared times z cubed divided by 4x squared. These two terms are exactly the same thing. I hope I didn't confuse anybody. Only thing we did was we moved that y to the negative to the top part of the fraction, and that made the exponent positive. X to the negative, we moved that to the bottom. Now that x to the second power is positive. And from there, we wrote out expanded form, simplified, combined like terms to get to our answer here. Hey, I'll be going over those negative exponential rules here shortly. Stay tuned. You don't want to miss it. Thank you for joining me. Math is easy if you take it step by step.